we are going to look at division of complex numbers. Amen. With example, we have, if we are asked to evaluate this idiot, 1 plus I, all in bracket, raised to the power of 3 divided by 2 plus I. We write solution. Is that clear? Okay. 1 plus I, all is raised to the power of 3 all over 2 plus I. Okay. We know that we can simplify this idiot I 1 plus I raised to the power of 3 by using Pascal triangle. But for the sake of malians in the class, even if I use Pascal triangle to expand this bracket, they will still get confused. So I'm going to break it down. It implies that if we have 1 plus I raised to the power of 3, this is the same thing as in mathematics, 1 plus I, all in bracket, 1 plus I times 1 plus I. It means this is the same thing as this. We are going to use this bracket to multiply this and to multiply this bracket. Now, for the sake of malians, I'm going to take it step by step. Let us just consider these two brackets. Then after the two brackets, any value we arrive at, we need to multiply the last bracket. Is that clear? So let's go. Okay? 1 times 1 will give you 1, plus 1 times I will give you I, plus I times 1. Note that we have invisible plus here. So if plus multiply plus will definitely give you plus, then use the I to multiply 1. It will still give you I. Amen. Then 1 I times I will give you I squared. It means you close the brackets. Don't forget the last bracket, 1 plus I. Amen. Look into these brackets. We can add the first bracket, two of us. Note that we can add I to give us 2I. So this bracket will give us 1 plus 2I plus I squared, all in brackets, plus 1 plus I. Amen. In complex number, you should also note that if I is raised to power 2, this is the same thing as minus 1. Amen. Are you following? This is the same thing as minus 1. It implies that anywhere you see I squared, you are going to substitute in for minus 1. Okay? So this will give us 1 plus 2I minus 1 instead of I squared. Do you agree with me? Then close bracket, open bracket, 1 plus I. Yes. Let us look at the first bracket. The first bracket, we have 1 plus 2I minus 1. Amen. It implies that we can add or subtract 1. It implies this and this will go. Amen. So this will give us 2I, the first bracket, all in bracket 1 plus I. Then let us multiply out the two brackets. If we multiply out the two brackets, we are going to have 2I plus 2I times I will give us 2I squared. Amen. Okay. 2i square. Amen. Okay. So now what we will do here is we'll now come back to this again because we are seeing I square. Note that I square, a complex number, is equals to minus 1. So we are going to write this is equals to 2i plus 2 all in bracket minus 1. Amen. So this is the same thing as 2i plus, use this 2 to multiply out this bracket. We are going to have 2i minus 2. Amen. So therefore, it implies that our 1 plus I raised to the powers of 3 is now equals to 2i minus 2. Are you following? Okay. So now, instead of writing this, we are going to replace it with 2i minus 2. Do you understand? Okay. So this is equals to our 2i minus 2 all over 2 plus I. At this point, we are going to rationalize. How? We are going to write this is equals to 2i minus 2. Amen?
Yes.
2i minus 2 times 2 minus I all over 2 plus I divided by 2 minus I. Amen? Okay? So this is the same thing as 2i minus 2 all in brackets, close bracket, open bracket, minus I, 2 minus I, 2 plus I, all in bracket, close bracket, open bracket, 2 minus I. Amen? We are going to multiply both the top and bottom out. Okay? Let's go. We'll use this bracket to multiply these brackets and use this one, the denominator, this bracket to multiply out this bracket. Out. That is what we want to look at. Is that clear? We have 2i here. 2i times 2 will give us 4i. Amen? Then 2i times minus I, it will give us minus 2i squared. Are you following? Then we are going to use minus 2 to multiply out these brackets. Minus 2 times 2 will give us minus 4. Then minus 2 times minus I will give us plus 2i. That is for the numerator. Let us look at the denominator. Are you following? Okay. We are going to use these 2 to multiply out these brackets. 2 times 2 will give us 4. Then 2 times minus I will give us minus 2i. And we have here plus I times plus 2 will give us plus 2i. Then plus I times minus I will give us minus I squared. Minus I squared. Amen? But note that a complex number, I squared, is always equals to minus 1. Note that I squared is equals to minus 1. So if you agree with me, this is equals to 4i minus 2. In place of I squared, we are going to write minus 1. Minus 1, amen, minus 4 plus 2i, all over the same thing applicable here. But if you look at the denominator, if you can see what I am saying, we have minus 2i plus 2i, just like minus 1 plus 1. Is that clear? it implies that this will give you what? 0. Are you following? So here, minus 2i plus 2i will definitely give us 0 here. It means we are going to have 4 minus I squared. For the sake of malleance, I will not introduce this minus 1, but let us have it in this form first. 4 minus I squared. Then let us consider the numerator. 4i minus 2 times minus 1 will give us plus 2. Amen. Then minus 4 plus 2i. Are you following? All over 4 minus, note that I squared is always minus 1, minus all in bracket minus 1. Is that clear? Okay. Without loss of generality, let us consider the numerator. We can add the real parts and the imaginary parts together. That is, the real and the real will be added, and the imaginary and the imaginary will be added together. But here we have 2 minus 4. This is the real part. 2 is the real part, minus 4, 2 is the real part. The imaginary parts we have here 4i and plus 2. So 2 minus 4 will definitely give us minus 2, and 4i plus 2i will give us plus 6i. Amen. All over. Note that we have here minus 1, invisible 1 here. So minus, opening this bracket, that is minus 1 times minus 1 will always give us plus 1. So we are going to have the denominator 4 plus 1. This is equals to minus 2 plus 6i all over 5. 4 plus 1 will definitely give us 5. Is that clear? Okay. So if you agree with me, one can stop here, but mathematically we can also transform this answer this way: minus 2 all over 5 plus 6i all over 5. Any question? No question? Okay. Thank you.